Alrighty. So, hi everyone. I don't know who's everyone, but I kind of want to say it, although it's just me and you guys right now. So, hi for both of you. I'm so thrilled to open our very first architecture transformers. Thank you very much. I love that name. I know it's awesome. You don't need to say that. We already know it's an awesome name. Yes, yes. And now I'm going to present myself because I've been talking for several seconds, not mentioning who am I. So my name is May Bason, and we have here Guy Menachem, but I think he can present himself, right? Go ahead, Guy.
Yeah, yeah,
Hi.
I'm Guy. Hey, man,
Yay.
I'm Guy, solution architect from Commodore. Very excited about this new series that we are going to have.
Yeah, because it's going to be super exciting. And oh, yeah, I didn't even say where I'm from or what am I doing. So maybe I'm this like super interesting figure that you don't even know. No, I'm kidding. So my name is May. Like I said, I'm a DevOps engineer at Forder. And yeah, let's begin. Let's talk about what is our topic for today. Guy, go ahead.
So today we are going to bring you like what is how scaling configuration management in deployment can look at scale. We understand it's a big challenge in many organizations, and May, I and Asaf spoke about it a few times, and we thought it's a great idea to bring everyone the ability to learn what other company do in order to face this big challenge.
Right. Yeah. So I think the first thing that we want to start with is let's talk about the impact. Let's talk about what we're going to have here today. Maybe we will convince you to stay for longer than 1 minute, which is the average for a YouTube video. I just made that up. I don't know what the average for a YouTube video. Let's just go ahead to the impact slide.
It, it's 30
So
seconds.
30 seconds. Oh my God. The humanity attention span. That's so short. Okay. So, first of all, I want to say that what we're going to do today is we're going to talk about a solution and we're going to look at the impact of this solution. And let's start with these things that we see here today. So, we have one command installation, we have Kubernetes free developers, and we have scalable configuration for more than 100 services. Guy, can you tell us a little bit about one command installation? What is that?
Yeah, so when we talk with Asaf first, and we are going to introduce it in a minute, we understand that one of the key challenges of how to do deployment, it's based on install the all product, all the services, all the third-party things that you need in basically one command. And we are going to talk about it, how amazing it's going to be to have this one command that you put in and the all product just deployed.
Well, that sounds super cool. But what I'm hyped about is Kubernetes free developers. Because before I was a DevOps, I used to be a backend developer. And although it's kind of cool to learn about a bunch of things that you're not getting paid to do, or is it? This way, developers can retain velocity and focus on the development of the product, which is their job, right? Many times, implementation details like infra tools them away from keeping their velocity. And we were able to remove the need for developers to know Kubernetes, which made them gain velocity and faster onboarding. Sounds pretty cool. So what else do we have? Oh yeah, we have scalable configuration.
And I think what's amazing about scaling configuration is sometimes that you hear about a solution that can work on a team of 5 or in a small startup. But when you take it to the next level of scalability, it's like a different way of craftsmanship. You need to understand how you do the onboarding stuff, how you do scale the environment, but also the configuration, and bring a solution that can scale up to a few hundreds of services. It's not an easy task to do. And that's what we did. So when we understand about the impact, I think everyone at home should ask themselves, like, why should they stay with us, right?
For sure. So yeah, I think that these are very good reasons to stay with us today. because what we're going to talk about is Helm charts and subcharts. We're going to talk about Git submodules and custom automation tools, which were all required in order to achieve those amazing points of impact. I think now is a pretty good time to introduce our guest. He's been sitting here all quiet and nice, smiling, waiting for his turn to speak. I think now is a very good point in time to do that. Hi, Asaf.
Hi, hi, thank you everyone. Thank you for having me. So I'll try to do it pretty quick and we go straight to the point. My name is Asaf. I've been serving in the Israeli military in the cybersecurity area. I've been in the cybersecurity and development field for more than 10 years. Basically, DevOps technology is, you can tell it's my hobby. I find it pretty cool that you can take a single line, build a castle with it, and now you can do whatever you want regarding basic, regarding business logic for your application. Right now, I'm the chief architect and R&D director at Weeb Security. So basically, what we do at Weeb Security is we are dealing with API security. API security is a field in cybersecurity that focused on business logic and application security, meaning we need to understand how application works in order to defend those. At Weeb, the way that we are dealing with this kind of security approach is to learn how the application works by sniffing its traffic, understanding from the traffic its behavior, and also understanding the application logic from a static code analysis of the source code. But that's enough about Weeb. And we are here to talk about how we scale our Kubernetes deployment. That's it from my side.
Yeah, let's get to the good stuff.
Yeah. We are thrilling to hear about API security, but I think the people are really thrilling to hear about configuration management.
For sure.
And before introducing yourself, like we talked and we pitched about the value and the impact you brought into the company in terms of scalable configuration and Kubernetes-free developers, something that any developers in the world would want to be. But we want to understand much better, like, how did you achieve the impact? What is the main thing that made you achieve this impact?
So that's a good question, by the way. I think that the main thing when you talk about cloud native and how to get, especially in a startup company, things pretty fast, is to try to decentralize everything. And the easiest way to do it is using open source technologies that the community is creating up in order to allow you to work in the cloud native area in a very high pace. So the main technology that we are going to talk about today is how we pack and how we build all the SaaS offering of Weeb. And I'm talking about Helm, of course. So I'll say a bunch of words about how we work at Weeb and why this decentralization is actually matter and how we use the open source and community technologies in order to achieve the impact that May and Guy said before. So basically at Weeb, we have multiple development groups. And the first thing in mind when you want to run fast and to develop fast and to deliver fast is you want to break the silos. You don't want a single man, a single person to do a job that everyone else could do if you would provide them a box to do it with. By that, I mean, it's pretty obvious that DevOps team would know all the guru details about how Kubernetes works. But in order to create a new microservice, once there is a pretty straight standard about how microservice should work, the DevOps team or the platform team just create a standard, provide that to the development team, and then everything just go in like a convoy or supply chain in order to provide the code into production without knowing what's going on behind the scene. So the way that we are using Helm is on both infrastructure stuff and application that we develop by ourselves. Every single line of code that we are creating eventually packed into a Docker image or Docker container. Every Docker container is packed as a part of a Kubernetes resource. And all these Kubernetes resources are packed into a Helm package. Let's call that right now a web Helm package. Now, beside that, an application is using a lot of other infrastructure tools such as a database, service mesh, message buses, and so on. We also do that at Web. We have a lot of data pipelines and ETLs that we need to maintain and execute. And we are using the favor of Helm and the favor of the community with the Helm subchart, meaning we are taking a lot of infrastructure pieces packed using Helm charts, and using the chart that we are building in-house and the chart that we're getting from the community, we are creating a 1 mega chart that is created upon with multiple subcharts. And with that, we can go to production without even know what's the infrastructure that's going to execute the Kubernetes cluster and the application is going to be. Meaning we are using Helm as an abstraction layer for packaging, and we are using Kubernetes as an abstraction layer for the infrastructure itself.
But wait, can you say a few more words about Helm for those of us that hasn't been like fighting with Helm over the past few weeks? You know, just the people that have been living the good life. Can you tell them a little bit more about Helm?
Yeah, of course. So basically, Helm is a way to tell what do you want to execute and how do you want to execute it. So these days, when you want to write a single piece of code, it's not just about writing the code, it's also about all the infrastructure and all the area that is to the right or to the left of the runtime environment that runs the code. Meaning, you write your own business logic, let's say an ETL that gets data from Kafka topic, need to do some transformation on top of that and send the process data into another topic. You need to understand, do I have the Kafka topics ready for me? How the infrastructure look like? How am I connected to this Kafka cluster, Kafka broker, and get the data from? And with Helm, it's very easy to pack within a single piece that been able to be deployed, that's saying this is what you need to execute, this is a container you need to execute, and this is how you should execute that within configuration that comes and packed within the Helm package. I hope it makes sense.
So just like, I know Helm, but I want maybe to add some clarification. So basically you package all the resources that you have and all their dependencies together, right? And then you can apply it on each one of the clusters that you want to run this package on?
Exactly. Yeah.
That's great. And this package deployment, this is what allows you to make this package the third party, package the configuration of Kafka, package your own backend front-end services into like this one Helm chart?
Yeah, exactly. Basically, Helm, it's like the RPM or the D package for Kubernetes application. I think that's the easiest way to describe what Helm is.
I think it's very interesting because it allows you, first of all, to package your things, also to like do the configuration management and the actually templating of these kind of things. But after we give this high-level overview, maybe we can discuss more about how did you implement or utilize Helm for that?
Yeah, of course. So as I said before, we have multiple development groups at Web. We're a pretty small startup, but when things are scaling and scaling pretty fast, you need to have some kind of control, and you need to allow the organization, the development team, to scale with you. as we said before, we want everything to be decentralized as much as possible. Now, in a lot of organizations, there is like a single repository that holds all the configuration files that are related to deployments and production and so on. At Weeb, we have decided that we don't want this kind of practice in our R&D department. So what we have decided is to distribute every configuration file that's related to a specific microservice to its own repository. We're not using a monorepo. For every repository, we have a dedicated, for every microservice, we have a dedicated repository that holds the code and the Kubernetes configuration that's related to the microservice. There are pros and cons, but we decided to go with a single repo for every microservice. And the way that we are building at the end a single Helm package from all of the different repositories is using subcharts. So basically what we do, we have a single repository that you can call it a monorepo, but basically it's a repository that connected to all of the other repositories using Git submodules. And once we want to create a single Helm package, a single Helm artifact for all of the microservices of Weeb, let's call it a Weeb version, we are fetching and updating all the submodules, everything automatic using CI processes. But the logic is to pull all the needed code, all the needed configuration that are distributed out there, build a single Helm package from a single place. But the good thing about it is that the developers doesn't need to know how it's done. So they have their own single piece of Kubernetes in their own microservice repository, and all the stuff behind the scene of providing all the needed subcharts from the infrastructure perspective, or all the other microservices that are not related to a specific developer, it's all done automatically in the platform team.
So basically, with the ability to distribute the configuration of each one of the services to its own repo, you were able to remove the need from developers to do the configuration or to go to other repo in order to do the Kubernetes configuration, right?
They're still doing configurations though, but only their configuration, and that's all they have to know, like, right? Or am I missing something?
You're right, May. At the end, when a developer creating a new feature, and let's say that this new feature needs to have a new environment variable or a new Kafka topic, or some other configuration that need to be related to this new feature, he needs to somehow inform the infrastructure his new needs. So the way that we are, the interface that we are providing to the developers is just using a values YAML file that comes with Helm, meaning the interface between the developer and the Kubernetes resources are very low, is very low. Most of the interaction with configuration is within value files and templating that we have created from day one.
I have another question. Can they create their own templates? I mean, so for us at Forder, that's very similar to the solution. I've been doing this little vibe because that's the solution that I've been working so hard on. That's why the big smile with like a little tear on the side. But anyway, I'm asking if the developers can create their own templates, or are there any restrictions to that? And do they even want to do that?
That's an interesting question. First of all, they don't want. Definitely. They hate it. They hate this kind of technologies. But engineers are very diverse, meaning there are more mature engineers, there are less mature engineers. There are engineers out there that want to deal with this kind of technologies, and there are engineers that want to just write Kafka streams and ETLs all day long. So they want the DevOps guy or the platform team guy to do it for them. That's from their intention and what they want to do. Do they have their option to provide a template of their own? They have the option, but in order to integrate the template into the single command installation, they will have to talk with us, with the platform team and the DevOps team, in order to integrate the new template, because we are looking for a very specific, let's say, pattern of a help template. And if it's not in the pattern, it won't auto-included within the deployment.
Yeah, it definitely simplify things and prevents from people trying out things that aren't supposed to happen the way they think that they're supposed to happen. But on the other hand, I guess sometimes, like I've met those developers that they do want to try and add their own thing, and they actually they will do the extra mile to investigate and learn and do the things like the right way. The problem with that is actually, keeping up, a level of things to look the same and to have like maybe formatting, stuff like that. And then it requires more effort on our side, to check on those things. I don't know. But yeah, I guess some people still want that. So we allowed them to have it, to have people editing and adding their own templates.
I think that what we see from many companies is that they always have this core that most of the developers or most of the teams use, which is the organization standard. They don't want to go into deep tech or don't want any specific configuration, especially if those teams do not need to perform in scale and stuff like that. They're like some backend service. But when you go out for the most critical business services, then the teams needs like something more advanced. And it's a good that you have, like in both of your teams, that you have solution for both cases, like for the core business that they don't need to do like configure less service, but on the other side you give them the way to template and to do the advanced stuff they need.
I mean, go ahead.
This is like one of the main cores of cloud native technologies and cloud native based development. It's about providing the agility and the self-service for the developer to do what he wants, but still remain in control and understand what's going on. So this is like you need to find, most of the organization are looking for the right amount of control within the right amount of self-service. And I think that there are edge cases that you need to implement, but they're not coming like every day. So if tomorrow a developer will come from me and say, hey, listen, I need this specific template into the deployment, it happened, let's say, once a month, once in a month and a half, 6 weeks, no more than that. So I'm okay with the process of making this kind of ask with a bit more friction and less self-service if it provides me more control.
So one more question about this architecture. So we talked a lot about the configuration and the Helm chart, and now you put everything on one single chart. What's going on with the Docker's images on the bottom side?
That's pretty basic stuff. Basically, what we do is we just run a Docker build in our CI infrastructure. We are using GitHub Actions. And we're just saving the images in our own registry. And once there is a Helm install of our package, the kubelet knows just to pull the images from our own registry. This is basically where the images are stored.
So a simple stuff, not a wizardy.
You want to keep it simple, as much as possible. There is enough complexity, so keep it simple where you can.
Yeah.
Great. So
Okay. Are you ready for the next thing, guy? We're waiting for you.
yeah, let's go. So we talked about the configuration at scale, and we talked about how do you package and the deployment. But the next stuff is how do you like do the one-click installation, and on multiple platforms. I think that would be great to learn a little bit more.
Yeah, that's another good question, another good topic that we have to invest, let's say, more than a minute and more than an hour in order to provide a good scalable solution. Basically, like every other cybersecurity company, we are dealing with very sensitive data for our customers. And most of our customers are requiring us to deploy the platform on premise, meaning that the data remains on the customer side and not going into some kind of SaaS environment that we are managing. The thing about it is that when things are going on premise, everything is going to the complex side, meaning you need to have more monitoring on this kind of environment. You have no idea what's going on over there. The installation of on-premises environments are known as a pretty complex. And this is the deals that you want to invest your time on, but you want to keep it simple as much as possible. So the ability to use Helm with another technology called Replicated, it's actually a startup company also based here in Israel, and that what's Replicated are doing is they are understanding how your Helm package is structured, all the dependencies inside, and they know how to create a single file, single zip file, contains all of the images, a container registry, a Kubernetes deployable package. It's called KURL. If you want, you can look for that later. You can Google it. And using Replicated, we have a pretty good abstraction for the on-premise environments, meaning we are creating a Helm package. Right after that, if we want to update our own SaaS environments, we are doing it using Argo CD. If we want to create an on-premise package to be installed on customer proprietary virtual machines, we just create the zip file that we talked about. We provide the zip to the customer, and then we continue the installation with him. So using Replicated and Helm provide us a lot of simplicity with a single line of installation, no matter if it's in the cloud or on-premise.
That's so cool. Honestly, I mean, okay, maybe cool is not the definition, but I find it cool. So there you have it. Okay, I think we're close to the end, right? We're almost at the end of this session. The last thing we have to say is just a big thank you, right?
Yeah, thank
Awesome.
you very much for sharing everything with us.
Yeah.
I had a great time.
And thank you for having me. It's been my pleasure.
Woo! First time. We did it. I'm super hyped. We're going to have so many people watching. I don't know, but I hope. All right. See you next time.